Access means what? Permission to use, right? Access. Control list. ACL, access control list. Some calls it as ACL, some calls it as access control list. Some will call it as contracts or permissions. Here we call it as access control list. What is access control list? It's a list that we write inside the router saying who is permitted to reach, to access the router or the resource that is in the network, like servers or some computers or some application running a device. See, access control list is not only preventing someone to access this router. Access control list that you write on this router can also provide access to use the inside resource to the router, towards the network. Both can be controlled using access control list. Access to the router, access to the network, passing through the router. Both can be controlled. Access control list is set of permit and deny statements. It's a set of permit and deny statement. Those host address or the network that we allow in the statement only can be reached. Those that are not allowed, even if you don't say deny, it will be denied. I have said something very important. You say permit. Let's say permit. There is alpha, beta, gamma. You are telling on this router, permit alpha. And you did not say anything about beta and gamma. You know what? Beta and gamma will be denied. And we call it as implicit deny. Implicit deny. It's not explicitly said. Explicitly, I have said only one statement, permit alpha. But because I did not say anything about beta and gamma, what the router will do is, it will deny. Did we write any deny statement? No. Even though we did not write, even though we have not written any deny statement, it is denied. That's why we call it as implicit deny. Now let's say the opposite. We want to deny alpha. Our aim is to deny alpha. So we wrote a statement, deny alpha. We wrote an access list, deny alpha. What about beta and gamma? We didn't say, will they be able to communicate? Will they be able to access? No. Why? Because there is implicit deny. I hope you understood. If you have said something about some source, when that source traffic comes to router 1, it is going to take that action. If you have said deny, it will say it will deny. If you have said permit, it will permit. When traffic comes from some other source, which you have not mentioned, that is going to be denied. So now all three are denied. See, when you have not written this, statement, all were permitted. Alpha was permitted, beta was permitted, gamma was permitted. But the moment you write deny or permit gamma, all the other will be denied because you did not mention anything about alpha and beta. Let's say you said deny gamma. You have said what? Deny gamma. Your aim is to deny gamma accessing this router or accessing the networks inside. That's what you want to do, but the problem is when you say deny or permit gamma, the rest, like alpha and beta, will be denied if you don't say permit any. If you don't say this word permit any, what is any? Permit the rest, permit the others. If you don't say this, this line will be right here. You did not write it and you can't see it also, but it is there right below this. Right below this line, this will be there. Deny all. Let me write in blue color, which is invisible, which we have not configured, but it will be there. What? Deny all. This will be there when you write this. This will be written, but you can't see. This will be dynamically written. But when you write permit any, this line will get pushed down. This line will get pushed down. Whenever you write another line, it will get added above this. So when you say after this one, when you say permit any, this has now gone down from there. From the second position, it has gone to third position. Because whatever you configure is going one above this line. Whatever you type, it will be always added above this. Because this is not written by us, this is implicit. So whatever you write will be added above. Now you see, traffic is coming from alpha. Is it matching here? No. Is it matching here? Yes. Any means what? It includes alpha, beta, delta. Delta, Omega, Omicron, Eta, Toyota, Maruti, Zen. You see, any. So alpha and beta will match here and it says permit. It will be permitted. It won't read this line. It will not read this line. You see, access list is read from top to bottom. When a match is found, it won't read further. If a match is found in the first line, it won't read the second line. For example, gamma is trying to communicate. It matched here. Denied. That's it. It won't read the second line. If alpha is talking, it is not matching here. So it will read the next line. It matches here. Any means it includes alpha, it includes beta. And it is said you have to permit, right? It will be permitted. Will it read the third line, the implicit deny line? No, it won't read. Did you understand so far? Any question? All right, so we have seen that access list is nothing but set of permit and deny statement. We can write many statements in one access list. But when a traffic comes, it will try to match the first line. If it don't match, then it goes to the second line. If it don't match, then it matches with the third line. Matches what? Matches the address of the packet coming. Which address? Source or destination? It depends. There are two types of access lists we will be learning shortly. One will focus only on the source IP address. It will check whether the source IP address matches. It won't check the port number. It won't check the destination address. It won't check the protocol. The access list that focuses only on source are called a standard access list. Standard access list. Only on source. The access list that focuses on protocol, source, IP address, source, IP, it may be IP address, it may be network also, destination, IP address or network, optionally the port number. It can also be called as services like telnet. Protocol is TCP, service is telnet. Okay. Telnet port number is what? 23. TCP 23. This is what we call it as extended access list. Extended access control list. If an access control list will check only the source IP address to decide whether to permit or deny, it's called a standard access list. If it matches protocol, source IP or network, destination IP or network, a protocol, service like telnet, SSH, you can also call this port number. Again, this is an optional one. This is not must. But these three are must for extended access list. To take an action, This 3 must match. Now whatever it is, whether it is standard access list or extended access list, it is read from top to bottom. When it is reading from top, if the match occurs here, it will not read further. It will stop right there in 4th line itself, because there is a match. And if that match says deny, it will deny. Now if any of this didn't match, you know what will be happening, because there is invisible implicit deny at the bottom. It will match here, which is invisible, and it is there implicitly. All right. So when we write access list, we have to mention the direction. Say for example, traffic is coming from down and going to this direction. Before it is sent out, you want to check these list, these lines, you want to check this list and take an action. So it is out, because when the traffic is about to go out, you want to check the list. If you want to deny before getting processed, right here itself, while it is entering, you can say in, while the traffic is coming in. If it is denied, then deny here itself. Why unnecessary CPU wastage and then getting dropped? So you have both the options, in, out. It depends on your need, whether to say in. When it is coming in itself, you deny if it needs to be denied. That's one option. Or after processing, when it is going out, you deny. But if you are writing access list, that access list should be written only in one direction, either in or out. You cannot say the same access list in as well as out. That will contradict, no? You cannot do that. One direction, one access list, one direction. Fine. Where do we write the access list? Yeah, we know it is written on the router, but where in the router? Is it in the privilege mode, or in the global configuration mode, or in the interface mode? Where do we write access list? See, access list we write on the, we apply it on the interface. I just now showed, no? If you are applying here, if you are applying here, then you will say out. If you are applying here, then you will say in, because traffic is coming from this direction. Yes, access list is applied on the interface, but before applying, where do we write it? We write it in the global configuration mode, global mode. We write it in the global configuration mode. Access control list is written in the global configuration mode. And then called under the interface. Okay. Any questions so far?
No, sir.
Okay, great. As I said, there are two type of access control list. One is standard, which will match only source to take action. Just the source matches only the source of the incoming packet. How router knows whether you are going to write a standard access list? Because in standard access list, it needs only the source. But when you write an access list, you should tell the router beforehand that you are writing standard access list so that you don't expect in the syntax you to give protocol and destination and port number. Because protocol, destination, port number is for extended access list. See, when you write an access list, to identify the access list, we give a number. If the number is between 1 to 99, then router understands that he is writing standard access list. So we should expect him to give the source only. If you're writing extended access list, it will match protocol, IP address of the source IP address or source network, destination IP, or the network. As I say, optionally, the service, the port number. How router knows that you are writing extended access list? When you give a number between 100 to 199, you see, you need to give a number to identify the access list. If that number is in the range of 100 to 199, router understands that this guy have to give me protocol, source and destination because he is writing an extended access list. Yeah. So access list are identified using number. When you use number, you no need to tell I'm writing an extended access list. If you put number between 100 to 199, router will know. We also have another way, named access list. This is called numbered access list. In named access list, we have to mention through the command that we are writing standard, extended. We have to put the command and say, I'm writing a standard access list. When you are going to use name instead of number to identify the access list. If you are going to use the name instead of number to identify the access list, you have to mention using the command that you are writing a standard access list. Okay, so there are two ways of writing access list. One is using number, another one is using name. Name, you have no problem. You can, when you write a named access list, you need to say, I am writing a standard access list. Then it will expect only you to give source. But in the numbered access list, we don't have a command called standard or extended. We just use the number. Accordingly, it understands whether you're planning for a standard access list or an extended access list. Is there any question so far? That's great. Now let us do a small lab where I'm going to show you standard access list using number. Now we have this topology, but if I try pinging from left to right or right to left, it won't ping. The reason is the router. The router do not know the route to reach 20 network. Show IP route. See, there is no route to reach the 20 network, which is behind RP. What we'll do is we'll write a default route. IP route, any network, any subnet mask, send it to 3000, or you can also say send it out. That's it. Nothing wrong in writing this. Instead of giving the next router's IP address, you can also say exit interface. Because it's a point to point, only two routers I have. I don't have third router connected to router A. There's only B router connected. So likewise, I'll go to B and write a default route, IP route, because this do not know the path to reach 10 network. So I write a default route pointing towards G001 interface. Okay, I've written a default route on both the routers and I have saved the config. As a result, I'll be able to ping from anywhere to anywhere. Let us try pinging from here to 20002, which is the server on the right. First one or two packets will be lost. You know the reason. It is because of ARP, address resolution protocol. I have to resolve the MAC address for every gateway in the path. Yeah, see, I'm able to ping from this now. I'll also be able to ping 20001, which is the computer in that 20 network. See, it's pinging. Now we are going to write an access control list to deny someone pinging server, let's say, or deny someone going to any device in 20 network, something like that, right? So let us now write an access list to deny only this guy. See, 10001, it can ping 20001. Earlier I was pinging from 10001, now I'm pinging from 10002. Earlier I was pinging, now I'm pinging from 10001. I'm able to ping from both the left hand side PC to the right hand side device. Now our aim is to deny whom? Deny 10001 accessing the 20 network. We do not want this PC accessing anyone in this network. But I want to achieve this by writing standard access list. There are two ways in which I can write. One is I can say deny 10.0.0.1, and without fail I have to say permit any, because if I don't say permit any, even the others will be denied because of the implicit deny. This is one way of doing. What is the other way of doing? Other way of doing is I say permit 10.0.0.2. That's it. And we all know that there is an implicit deny. It will deny all the rest. Because there is only two computer, I can do this. Because there is only two computer, I can do this. But this is the best way. This is the best way. All right. So that's one thing. Secondly, where do we write? Where to write? We have to write standard access list as close to the destination. Where is the destination? Right side. So I have to write it in router B, not in router A. I repeat, if you are writing a standard access list, write as close to the destination. When you are writing extended access list, you need to write as close to the source. Extended access list as close to the source. Standard access list as close to the destination. Are you clear?
Yes, sir.
Okay. Now let us write one standard access list on router B. As I told you, you need to write the access list in the global mode, global configuration mode. I'm saying, so let me write down here access list. You see, if you're planning for a standard access list, the number available to identify the list is 1 to 99. So I'm going to say 1, let's say. And then I say deny. Because I want to deny only one computer, I need to use the keyword host. And what is the host IP? 10.0.0.1. I want to deny this guy. And without fail, I have to say permit the rest. Permit any means, all the other. If you don't do this, if you fail to do this line, everyone will be denied because of implicit denial. You see, this is why we call it as list. There is not just one line. There may be more than one line. That's why we call it as list. Access control entries. There are two entries. One is deny host 10.0.0.1. Another entry is permit any. Now I need to bind it to the interface. If I am binding it on G001, if I'll bind it on G001, because the traffic is coming like this, I have to say in. As the traffic enters in, I want to take an action according to this. If you don't like here, if we wish to have it on the outside, while going out, when it is about to go out on this interface, if you are binding it, then you need to say out. With this router, with respect to this router, you have to say in or out. With respect to the router, you should say in or out. Not with respect to this destination. Don't see the destination. With respect to the router only, we have to say in or out. This in or out, you should not get confused. Okay, now I'm going to bind it to G000. I'm going to say interface G000 IP access group 1 out. I just put O, it means out only. Is it clear? See, direction you should not see from where it is coming, where it is going. Because you are writing on this router, if I want to take action as the traffic enters, then it should be in here. If you are going to bind the access list here. If you are going to bind it on the other interface, then it should be out, because after processing it is going out. This is before processing as it comes in. You understood?
Yes, sir.
All right. So I have said out because I'm writing on G000. Now copy this, copy. Let us do the verification. You see, the command is show IP access list. This is the access list we wrote. This 10 and 20, it comes automatically. It's a sequence number. We did not give. We said access list 1. I hope you noted this command out. So now I'm going to ping from 10001. It should not ping. You see? It says destination host unreachable. Who is replying? That second router 30002 is saying, I'm sorry, I cannot reach. And I cannot even reach the other server nor the computer. But when I ping from the other PC, from here it is pinging. Because this is matching with the second statement. 10 packets pinging, 15 packets pinging, no, ping to 15, 8, 8, 9, 10, 11, 12, 12 packets. So I should see 12 packets in the permit. You see, 12 packets matched here. I was pinging from 10002, and 8 packet matched here because I was pinging twice, one to 20001, another one is to 20002 from this address. See, before pinging we were checking this, there was no match, but now you see match. Now let me try pinging again, and you will find the again another 4 packet, again now another 4 packet. So now in the deny host 10002 there should be 16 packets. Let's check. Yeah, it's 16 packet. Now when I ping from the other computer, which is allowed to ping, it gets matched in the second line. You see, earlier it was 12, but now it matched here. Is it clear?
Yes, sir.
Great. So we have seen what is access list, and in that we saw standard, extended, and we can write using number or we can use name. And now we have seen an example called numbered standard ACL. In our next session we will be doing numbered extended ACL, and then followed by named standard, named extended ACL.